Live streaming is on.
Told you so. All right. So, hello and welcome. We're going to get started here in just a brief moment. Our chaos is settling. This is the first Code and Supply event that we've streamed in a while. I think the last few we decided not to stream because the folks were not comfortable with it. That's completely fine. We're willing to work with folks when that happens. Yeah, Lightning Talk night. So we are Code and Supply. If you haven't heard of us and you're just catching this live feed now, we're a group of software engineers, designers, managers, product managers, project managers, everybody who goes into the process of creating software. We're headquartered in Pittsburgh, Pennsylvania, and we throw conferences like abstractions and artifacts and uptime. We do meetups whenever there's not a global pandemic going on in person at our co-working space that we run in East Liberty, part of Pittsburgh. Beyond that, we love talking on our Slack. You can check us out at codeandsupply.co/chat if you'd like to get in on our Slack. We have a pretty good program for you tonight. We've got, I think we're at 9 talks coming up on a variety of topics. This really is an awesome grab bag. And I'll try to keep the Code and Supply interstitial ads to a minimum. But I do want to try to encourage people to engage with Code and Supply in more than just chatting ways. We do have bills to pay, and we'd like to be around for the future. Fortunately, we've been able to survive the pandemic pretty well so far. At least we haven't gone out of business yet. So, yeah. Anyway, Lightning Talks. So, first up tonight is going to be Phil Pennock. Our Lightning Talks will be 5 to 10 minutes. At 5 minutes, I'll just kind of make an indication, a light indication. At 10 minutes, that is when I will probably cut people off. And that's about it for my administrivious type stuff. Phil, take it away.
Hey folks, I hope everyone can see the slides. I made the mistake of using Linux on my laptop, and don't you know it's going to be the year of Linux desktop, so I don't have working audio there, so I'm split between 2 systems. Systemd. Anyone who's followed along with distribution wars and the like has heard all the arguments or dodged all the arguments as people have screamed and shouted about how wonderful it is, how horrible it is. The developers are wonderful, the developers are evil, and all the rest of it. And for the most part, I'm on this. I was on the outside for a long time. My OS of choice is FreeBSD. Init system wars are something only a geek can love, but over time you have to start using it. And once you start using it, you start finding the things that actually are quite nice about it. And earlier this year, I reached the point when I was bringing up a service on FreeBSD and found myself quite upset that I did not have systemd's management facilities available for me. And I had to go back to RC scripts. So it's quite a turnaround. So a classic init has 2 basic jobs. Start everything that's running on your computer and reap all the processes which where the parents exited, which is a minor thing, so don't worry about it. There are fancy things you can do. People have tried concepts of run levels. So in practice, there's only ever one which is used, the real one. And ultimately, it comes down to when the kernel starts, when it's ready to start userland, it does 1 fork into userland and sets things up, and it runs the init process, and that's it. The kernel does not directly start anything else. Every other process is forked in directly or indirectly from there. And you'll find various systems for this, and there's rc.d directories, init.d directories, but ultimately it comes down to one process just working through them in order, trying to start them and running things. Systemd does a lot more. I say it causes debugging woes. Twice in the past week, I've had to help people with GNU-PG problems where it turns out they had upgraded their software, but they didn't realize that the user systemd was using on-demand socket activation to start their assistant daemons and was starting the wrong versions. And so when you don't know it's there and don't expect it, yeah, debugging woes. But what systemd does is it moves us away from we're starting a process and we don't care beyond that to, there's a bunch of things that go into a working computer system and they have interdependencies and we can want to do things in response to other events. We can plug storage in, we can bring up network links, and we might want to do things when that happens and only when that happens. And so we switch instead to this rather rich object model of services, timers, sockets, and other things communicating via an event bus. And rather than leaving people to figure out the right way to invoke various wrapper commands to constrain what a process can do, we instead have a declarative configuration language in the file for saying, don't give this read-write access to most of the system. It doesn't need it, shouldn't have it, shouldn't even be able to see what's in home. This is a system service. It gets access to this tiny, tiny bit of the system, and anything else, you're on your own. And it ties into logging and the like, and there were arguments about whether this was good or bad, but journal control is quite nice. And so overall, you have a much richer system. So what does this look like? First, everything is its own C group. The extent to which this is its own network namespace, its own user namespace, anything else, is controlled via the configuration. But you have it, so the namespace is separate from C groups, but all those namespace controls can come in along as well. But because everything is its own C group, systemd keeps track of everything. I have friends who run Nginx with embedded Lua scripts of hundreds or thousands of lines, and service restart is a nightmare for them because somewhere in their fleet something wouldn't restart. System control, when you stop it with the default kill mode, it will eventually end up killing everything. There's nothing hanging around. The output you should be able to see on screen is from systemd cgtop. Cgtop and cgls subcommands are worth knowing about. This is from my laptop earlier today. Slices are container groups. So everything in the user slice is me. Everything in the system is the system running. You can see them running HashiCorp Vault and various other things. And there is accounting. Isolation. I said that instead of having to figure out from scratch how to set up wrapper commands to constrain access, we have things like no new privileges, which means that set UID calls will fail. So even if you've got a vulnerable set UID program around or sudo is available, if you turn on this feature, your service running into this will not be able to use it. It will be ignored. Lock personality matters if you've dealt with any of those attacks based on weird DOS things and memory page zero and all the rest of it. Just if you're running a Linux program and you know it's Linux, you don't need the attack surface of 5 other different operating systems. Lock the personality. And yeah, there's various things here. You can see they're fairly self-explanatory. The strict SUID means that you won't be able to add set UID to bin sure. This is great. A private temp. So anyone who's ever dealt with time of test to time of use file system attacks with race conditions in /temp, if every service has its own private temp, these are no longer an issue. So isolation is quite nice, and having it all there from scratch raises the table stakes. A lot of what systemd has done is just raise the table stakes for anyone wanting to be an init system, or good or bad. Lame duck mode support is things like give it 40 seconds and send it this signal to exit. This is something I'm using on NATS server, NATS open source message bus thing, my employers. We send it to user 2, the service goes into lame duck mode. When it's finished evacuating everyone, it will shut down. We give it 40 seconds to do so before we kill it. This is just there out of the box. Statistics collection. You turn on these 4 little booleans in the config file, and suddenly we start having things like tracking of how much memory is being used, how much CPU, how much network capacity. I haven't gotten around to checking, but given that netstat-s has a whole bunch of statistics on what's going on, I'm guessing that this is just a network namespace, and those statistics are now by namespace, and so it's no additional overhead to keep these, which is great. So we can see this NAT server running has had 6 meg in, 3 meg out. Being able to see what's actually happening in terms of network capacity on a per service basis, quite nice. Templating. This is something I set up for my employer. We have a service. We run multiple copies on a machine sometimes for good reason. We create a template for the systemd service, and then we instantiate it. So this is foo@.service is a config file. Then foo@thread, foo@gladys will be the symlinks we create, and ultimately you end up finding that suddenly you have one environment file source for all of them per template instance environment file source, and it's a rather nice way of just being able to apply settings across all of them. This is an example I grabbed in from Vault because here you can see ambient capabilities. If you've ever dealt with things like binding port 80 and whether or not a non-privileged user can do so, you'll have found the catnet bind port or something like that. I forget the exact name. You can set the capabilities there and suddenly you can continue running as an unprivileged user and it will just work. And there's so being able to manage your capability sets and your namespaces and your mount points. Here you can see we've got protect home read only. For various reasons, my Vault instance needs to be able to read certain things out of home, but doesn't need to modify anything. It doesn't need to write to temp or to etc. or anything else. So I've tuned the permissions available accordingly. Journal control is how you interact with the journal. The journal are the logs. The logs are one big pool. They can be rotated and so forth, but they're kept on a per service basis. Here you can see a hint of the fact that there's 2 separate systemds running when you're logged in a box. There's the system one and your personal user one. And so you can do things like get the logs for all the logs for my stuff since 5 minutes ago. So every time Slack's spewing crap out to the console logs, that's how you find the recent ones. And you can find all the logs for Vault since the last boot. And okay, you can do a lot of that with grep and the like, but it's there. And there are config files and etc. So you can set up automatic rotation and retention periods and the like. Timers, replacing cron, and a few other things. Here you can see that 60 seconds after boot and at a particular time every day, this timer will fire. I don't want it to be precise. I don't care that it's exactly that time. I want it about 5 minutes and sleep a bit around 40 seconds, because if you dealt with systems which deal with customer load, you'll see the them suddenly maxing out on the minute every minute because of everyone's systems being synchronized to the clock. If you care about reliability, you are asking your systems to be a client at some random offset from the minute. And instead of having to have this logic in every application or every wrapper for the application, systemd has it when the timer fires. So you just set the accuracy you want, randomized delay, and away it goes. And then we just have the service which depends on it, depending on this timer. This is just something which is updating some DNS zones as an ancillary thing, which I threw together. And here you can see the thing it's actually running. It's invoking a particular script as a one-shot because it's directs, it's not a service, running this particular user. We're nicing it. It's a background task. I don't want it interfering with anything else. We nice it out of the box. And we give it access to particular address families, and we give it read-write paths of var cache unbound. That's where we're going to write to. That's how it communicates. That's the extent of it. And the fact that I have quite a bit of degree of confidence that nothing else is being written to by a service means I'm a lot happier with running services written in C or the like. Systemd gets rid of a lot of the need for using Docker for running services.
Got about a minute, Phil.
Cool, because I'm almost finished. I'm zooming through this. Socket activation. If you've ever dealt with inetd or the like, and being able to not start a service immediately, socket activation is what you've used with wait mode services and the like, or in this case, based on Unix socket path. So this is it from a user service. %t is going to be var run 1000 for me. Systemd is creating this Unix main socket. And when something connects to it, at that point, systemd will start GPG agent and hand off the socket to it, and GPG agent will then accept the connections. And there are a lot of manual pages. These are the main ones to know about. Exec has everything to do with running the command itself. .service is the stuff around the life cycle of the command and what it means to execute successfully or the like. And unit has all the stuff around basic syntax and support and the like. If you know to start with those three, you'll be a lot better close to finding that systemd has comprehensive documentation, but it's not always the most accessible in finding cross-referencing. And apropos systemd, man-k systemd will get you the rest. And that's it from me. Any questions? Are we doing questions or not?
We could take one question. If anybody has any questions. All right, seeing none,
Okay.
we shall
Thank you, folks. Bye.
proceed. All right, cool. So that's talk number one. Cool. Thank you very much, Phil. This is Lightning Talks, December 2021, with Code and Supply. I do want to point out that we do have a membership-supported organization. Membership starts at $10 a month, $20 a month gets you some day passes to our workspace, our co-working space, and a few other cool things. And then we've got, of course, co-working memberships starting at $100 a month. So check us out at codeandsupply.co/join. So in a little bit of a break from normal things, I usually don't talk at Lightning Talk night, and I just so happened to have given a Lightning Talk at work on something just a few weeks ago, and thought it would be a really cool talk for this event. So here I go. All right. Give me 1 second to make sure that I'm all set up and ready to go. Except I lost my window behind another window. There we go. All right. So, hi, I'm Colin Dean. I'm a software engineer for a retail company that seems like it might sell archery sporting goods, but really we only sell children's toys related to archery. Yeah, that company. I run here this here community, Code and Supply, and you may have heard of a nonprofit wireless ISP that I helped to start called MetaMesh Wireless Communities. I'm going to talk about classifying work tickets. You know, those things you're supposed to file and update between planning meetings. There's this really cool organization at CMU called the Software Engineering Institute. These folks published a book called Software Architecture in Practice many years ago. A then coworker and Code and Supply member, Michael Keeling, introduced me to this book and several others as well. And I went all in on it. Absolutely love this book. One big takeaway on this was this particular diagram, or at least this is my reimagination of that diagram. I decided to classify my project's tickets according to this diagram. This has served me well now across 3 companies and several teams. I'm going to talk about what exactly these quadrants are. So the first on here is a user story. User stories have some kind of a positive value and they're user visible. An example of them would be we're going to modify the user interface, or we're going to modify a model algorithm if you're in a data science pipeline. We're going to conduct user research, something that the user is going to see, that the end user of your software is going to experience when consuming your software. An architectural story has positive value, but the user doesn't see it. These things get into building backend services or pipelines, implementing a new algorithm, maybe standing up a new pipeline. These are generally considered the best practices as of implementation. That is, you don't want to go too deeply into the weeds as in like fixing things as you are building them, but rather you're going to do your best as you're writing it. Defects. These are pretty clear. They've got negative value, and they're definitely user visible. Good examples of defects. The current behavior produces a result the developer didn't expect. That is basically the definition of a defect there. Fixing an environment outage, that's a defect. Fixing security problems. Maybe a button should be red when it's actually blue. Something like that. Technical debt. We love to talk about technical debt. There's lots of different discussions on what actually constitutes technical debt, but it's always a negative value, and sometimes the user can't see it. And actually, generally, the user can't see it. Good examples. We want to improve performance. We want to update dependencies like log4j. We want to automate some kind of manual process. I always like to think of tech debt as we're moving towards some kind of best practice. We know the best practice, but now we want to move towards it. And that's the work that we can hold off on for a time, but we can't hold off on it for too long. One team member who's been around the industry for decades said that this practice was like collecting the corners that we cut during development into a jar so that we can pull them out and reattach them later on in the project. This manifests in reality as creating a set of colored labels: user story, arc story, defect, and tech debt. Sometimes you can leave off the dash or make it an underscore. It doesn't really matter a whole lot the style that you do it, just as long as you've got these four, and they should be colored approximately these colors. That way people who are familiar with the quadrants will know what you're talking about. Ideally, you want to require, if your system allows you to set requirements for labels or tags or something, require at least one of them. Optionally, there's some other classifications you can get into. You can call something documentation. And this largely comes down to documenting team procedures. And this gets into completionism of tagging in your work tracking system. Remember, product documentation definitely falls into one of the other four quadrants, because documentation is a product too. Documentation can have tech debt. It can have defects. It can have architecture. It is real product for that matter. I've also commonly gone into like discussion or question. This gets into like decision meetings, trying to keep debates in a ticketing system, and separating the work product from the process used to produce it. This is good for saying like, oh, we got to have this meeting and it's going to take a really long time. So we want to track that in our work ticket system and maybe assign some story points to it or something. Another good process here, architecture decision records. These will send you down a good path for that's a good documentation process. And architecture decision records themselves can be architecture stories. My team right now, we end up putting these into like a documentation or a discussion section, because we know that they're going to take time for us to come up with a good proposal to change our architecture, which is exactly what an ADR is meant to do. So yeah, they're a product. When you think about these classifications, here's how you want to present them. If you've got lots of red, you want to work on some defects first. If you've got lots of black, that means you've got some debt to pay down, or maybe you want to prune the backlog to get rid of outdated ideas. If you've got lots of yellow, that means you want to measure the value of the back-end improvements. Maybe you have some things that are low-hanging fruit that can be banged out real quick, or maybe there's this like whale of a ticket that needs to have some work done on it soon. You know, if you've got lots of green, the users may need to experience changes, so you need to potentially work with other teams within the company, within the organization, to say, hey, we're going to have some user interface changes. We need to prepare PR. We need to prepare our documentation team, things like that. These can be really good visual indicators of the work that's coming down the pipeline. So TLDR, label your tickets, use these 4 categories. colorize them to make them stand out. You can do this really easily in JIRA through like card labeling, card colorization based on labels. And remember that documentation is part of the product, and that decisions should produce documentation just the same. That's it for me. Any questions? No? All right. Oh, I see somebody did ask about defects. A question about your definition of defects. You said it includes a result the developer didn't expect. How do you suggest classifying results that the customer didn't expect? Well, that definitely falls still into defects because it's, I think the exact language, current behavior produces a result the developer didn't expect. If the developer didn't, if the customer expects something, but the developer did expect it, or didn't expect, the customer didn't expect it, but the developer did expect it, then that comes into a user story where there needs to be research done to understand if the customer expectation is aligned or misaligned, and if there's something other, something else you can tell the customer, or it could result in could result in a change, but it's generally not a defect in that case. All right, that was my one question. And let's move right on to the next person, since I was just talking. Simon had to not show up. So we're on to Tiemoko.
Okay, let me share my screen here.
Share. There we go.
Can everybody see a slide deck?
Yes.
Okay, awesome. So my name is Tiemoko, and I'm a cybersecurity researcher. And today I'm going to be talking about safe and portable data structure design in the Rust programming language. So before I get into the specific content, I want to provide a little bit of context on the memory safety problem and how well we're doing at it. So memory safety bugs are things that are typically associated with C and C++. So you could have stack or heap-based buffer overflow, use after free, double free, iterator and validation, etc. And what these bugs have in common is that even though they are not always exploitable, in the worst case, the attacker might get an exploit that gives them Turing complete control over the target process. So in the risk calculus, that's like a very, very bad scenario. Now, there's also a problem that's been around for quite a long time. So there was a seminal 2012 research paper that looked at 30 years of failed C and C++ memory protection schemes. So 30 years meaning from about 1980 to 2012, and failed meaning bypassable, both in theory and in practice. And if we fast forward to 2021, out of bounds right, a memory safety bug is the #1 vulnerability of the year still, according to MITRE's top 25, which is kind of an influential and well-regarded index in the security industry. Now, the good news is we can actually do better. And a big part of that is the kind of innovations that the Rust programming language brings to the table for contexts where garbage collection is just not feasible. So we're talking about high-performance distributed systems or small embedded microcontrollers. But it's not the case that simply writing a program in Rust makes it safe or portable. It's a little more nuanced than that. There are kind of some idioms and techniques that we need to understand, and that's what this talk is about. So I want to talk about designing a Rust data structure library that has two properties. First, it's extremely portable, so we can run it on the biggest of servers or the smallest of microcontrollers, even if there's no operating system and no memory allocator. And second, we are gunning for the provable absence of memory corruption bugs. And what I mean by provable is we're going to use the strengths of Rust's formally verified type system to do compile time static analysis, which reasons about any possible execution of our program. But when I say provable, I do not mean absolute, right? Because the Rust compiler, for example, is something that is being updated every day and written by humans. So there may be a bug introduced, and there's generally no such thing as absolute security against any threat model. Now, the techniques that I'll be discussing apply to any kind of tree or graph data structure that you might want to implement in Rust, but they're based specifically on my experience working on an open source library. And the goal of this library is to provide an API-compatible alternative to Rust's standard library so that developers on resource-constrained embedded systems can use the same ergonomic APIs that developers that can use the standard library on their platforms are able to access. And one of the goals is also to take some APIs from the nightly toolchain and make them available on the stable toolchain. So I want to start off with kind of how ordered sets and maps work under the hood. And they're typically implemented with some sort of self-balancing tree. So in Rust's standard library, that's the cache-friendly B tree. If we look at C++ or Java, that's the more traditional red-black tree. And the reason we bother using these kind of trees is that they give us log n retrieval time. So because we're typically doing something that's close to binary search. So you can look at the example on the right. This is kind of the running example that we'll keep in mind for the rest of the talk, where we have a parent node. Because it's a binary tree, you can have up to 2 children, and the left child is smaller, the right child is greater, and this is the thing that we can run binary search on. So if we think about what that looks like in memory on the heap, when an OS controls memory allocation, we don't get to control where our nodes go. That's kind of done for us. But we still have a logical tree in this diagram because we have the parent node 2, which has owning references to its both of its children. And you can think of these kind of like pointers in a C-like language. Now, the problem we quickly run into in Rust is that a lot of graph or tree traversal algorithms really require the children to have kind of what is called a backward pointer to the parent. And this actually breaks Rust's ownership semantics because now it is unclear to the Rust compiler whether 2 owns 4 or 4 owns 2. So the Rust compiler needs to know when a variable goes out of scope, how to drop it or how to deallocate memory. And this backwards pointer situation actually makes that undecidable. So now we're going to get a compile time error. So in the solution space, there's actually 3 approaches to dealing with this. I'm calling them the good, the bad, and the ugly. So the bad approach is we can use Rust's unsafe keyword and just drop into C-style raw pointers. And I don't mean that this is morally bad. A lot of very useful real-world Rust software does this. But I mean it's bad for any kind of provable assurance because raw pointers can point to anything. They can point to nothing. They can be invalid. So we really can't say anything at compile time about the safety of a program. Now, another technique is what's called the interior mutability pattern in Rust, and that's essentially using the language's smart pointer capabilities. And I'm calling that the ugly approach because it makes code very kind of hard to reason about and maintain. So if you have a junior developer on your team or maybe an intern, this is something that might cause them a little bit of grief. So what I want to talk about in the next slide is something called arena allocation, and that is our good approach because while we still have some runtime checks that are associated with the ugly approach, we actually get code that is much more portable and also kind of cleaner and easier to reason about. And arena allocation is not something that is unique to Rust, but it's something that's been around in the Rust community for a while, as early as 2015, according to my research. So what is arena allocation? Well, we can take our logical tree and we can actually store it in a vector. So that means we have continuous and homogeneous elements stored right alongside each other very tightly instead of being scattered all over the heap. And that looks like the diagram that you see on the right. Now, the order of these elements, the fact that it's 142 versus 214 or something is not consequential because that's just the order that they happen to be inserted in. But the idea is that even though we stored these things tightly, we can still kind of build up a logical tree. So if we scan this left to right, we can see that the first element in our array is actually a leaf node that has no children. And we can say it has a backwards pointer to the parent at index 2. The same for that middle element, the 4, still no children. And then when we get to that last element, our root node 2, we can say, well, it actually has 2 children. One lives at index 0, which is the 1. The other one lives at index 1, which is the 4. So we have a tree represented that way. So the idea here is that we're kind of decoupling the physical representation in memory of our data structure from logically how it works, right? Because we still are maintaining this sorted and searchable tree. Now, this kind of reframing actually buys us 2 really, really good things. The first is that we can write very portable code because assuming we know the max capacity of a collection, so let's say that our business logic dictates that we only have to support sets of up to 10,000 elements, we can actually pre-allocate all of those on the stack, which means that we never need to use the heap, which means that we never need to be reliant on the presence of an operating system, which then means that we can run on the tiniest of embedded microcontrollers. Now, we also get safety here because we're not using raw pointers. We're not doing the interior mutability thing. Although we still do have to do some bounds checks at runtime, the Rust compiler is actually smart enough to optimize those away in certain cases. So we're in very good shape. Now, we've got a memory layout that lets us be safe and portable, but then we still have the question of, well, is our code actually robust or correct? And unfortunately, we can't be sure, because we could still access that vector that I showed on the earlier slide, that arena, by index. And if that index is out of bounds due to a bug in our code, the Rust program will terminate or panic. And this isn't as bad as an out-of-bounds access in C or C++, where we're now reading or writing arbitrary memory. But if this is, say, an OS kernel and we panic, then we just lost everything running on top of the entire operating system. So that we still don't want that kind of situation. The other question is correctness, because because we swapped around the way things are represented in memory doesn't guarantee that our set or map actually returns things in a sorted order, or doesn't drop elements or insert elements that shouldn't exist, etc. So the last thing I want to talk about in this presentation is something called differential fuzzing. And it's a technique that lets us validate both reliability of our library and also logical equivalence to the standard library. So at a high level, what we're going to do is say the standard library is a known good model because it's used by millions of people. It's had hundreds, maybe thousands of commits over the years, so we can trust that it's correct. And then we're going to stress test our APIs. We're going to call them in random order and with random parameters, and we're going to pass those same inputs to the standard library and check that the two implementations always maintain a lockstep. Because if we see any divergence, that means that somebody's wrong. And it's either us or standard, right? So it's probably us, and we might want to know about that. So when we run a differential fuzzer, what it looks like is this. And I know that this probably just seems like a lot of terminal scroll, but there's actually a lot of very cool things going on here. So this is coverage-guided fuzzing. We're using a basic block level coverage to generate test cases that see more of the program. It's structure-aware because we understand API semantics, and it's differential because we have that model to compare against. And I've left a link at the bottom of this slide for a project called Cargo Fuzz that lets you use LLVM's libfuzzer, which is a really awesome fuzzer maintained by Google to stress test your own code. That's something you could definitely check out because it's free and quite powerful. So in conclusion, with the Rust programming language and kind of reframing of our problems, we can get portability to bare metal environments where we have no heap and no garbage collector. We can get safety because we have first-party static analysis that provably eliminates very, very vicious C++ bug classes. And we can also get speed because Rust is generally comparable to C and C++ in terms of runtime performance. A lot of benchmarks kind of put it within a single digit. But the number one thing I want you to take away from this talk is that safe Rust is like a limited kind of formal verification. So limited because we're only proving one domain agnostic property, which is memory safety. And that's a very, very important property if you want programs that are reliable, that don't crash and aren't exploitable in very, very horrible ways. But that verification is also practical because Rust is a commercially viable language. So it's not the case that you need to be a mathematician who can work with a proof assistant. There are businesses that are shipping code at the speed that competitive business dictates using the Rust programming language. And finally, on the verification from the verification angle, fuzzing you can think of as a supplemental stochastic validation for properties that the Rust compiler cannot otherwise prove or reason about. So thank you. That's all that I have, and I'm leaving a link to the library here, as well as my blog and a online handle if you have any questions or need to reach me.
Awesome. Thank you so very much. That was a great talk. Absolutely great talk. I love Rust content. Do we have any questions? Any questions for Tiemoko? Tiemoko, that was your first Code and Supply talk, right?
Yes, it was. Although while I was a student in the Pittsburgh area about 5 years ago, I would come to Code and Supply quite often. So I'm very, very happy to be back.
Cool. Yes, very happy to have you back. All right. Next up is Yvette. Yvette, are you on? Yvette's going to be talking about Code and Supply stuff.
I don't see somebody who looks like Yvette in the names.
I don't see her on either. We might come back to her. Let me give her a quick ping. While I'm going to do a quick commercial break of sorts while I am talking about various Code and Supply things in it. So yeah, we've got a job board at codeandsupply.co/jobs. We have, I don't know exactly how many are there right now. I'd say it's probably about 24 jobs posted or so. it's really inexpensive. You need only be giving Code and Supply money in order to be able to post jobs. So if you join at $10 or $20 a month, you're able to post your jobs, and jobs would get syndicated out to Twitter and to Slack and a few others. And they go out on our RSS feed and, of course, on our website. So we would love to see more jobs posted there. People tell us all the time that they like our job board because it's simple, that we ask for a pay range in the description and some other cool things. They also go out in the occasional Code and Supply email newsletter that generally goes out on or around the 15th each month. I think I may have forgotten to send it out last week, but that's probably going to happen tomorrow. And because that's still a manual process, there are still manual processes in this organization. Yvette is a little bit delayed, so we're going to get her next. So maybe we can get Theo up next. Theo, are you there?
Sure.
Awesome.
Sounds good.
All right. Where are you? Is your video on?
Nope. I can turn it on.
If you want to,
There
all right.
I am.
There you are. If you want to go ahead and share your screen, and you can
Good.
start.
Awesome. So I'm Theo Larson. I am a software engineer at a company called Grouparoo. We're an open source reverse ETL tool for data engineers. So we help companies get their data from warehouses to tools that they use it in. So I'm going to share about recently we went through and redid a bunch of our front-end code and moved to Modular Sas. And I found a cool at role that Sas has implemented and is shifting towards, which is the use at role. And I'm on the wrong screen. There we go. So Modular Sas was a big shift for us. It was essentially going from one giant style sheet for our entire website and splitting it out such that styles that are only for specific pages are paired with that specific page. So we have, one style sheet that is for a blog and another style sheet that is for other individual pages, and they're separated out so that the code isn't, you're not loading up styles for pages that you don't need. It also introduces namespacing. So each class is given a GUID when the Sas is compiled, meaning that if you have, for instance, a card class that's utilized on 2 different pages and you didn't give that class a prefix, it's just called card, the Modular Sas compiler will give it a namespace and its own unique class name such that they do not collide, and the correct one is applied at rendering. Some of the way that it used to be imported was using the import at rule. And I went to look that up on the Sas docs a few weeks ago, and this is the lovely warning that is in its place. Sas strongly discourages the continued use of the import rule. This does not pop any warnings when you compile it or build it. It's just hidden in their docs that they are phasing it out, I believe, over the next year. So in favor, they have started phasing in the use at rule. And so use is pretty neat. Import was great because it allowed for things like third-party packages and modules to be imported and used. You could do things like define your color variables and use them to override Bootstrap's default theme, things of that nature. And there were some issues with it. You ended up with a lot more CSS than you need. So import would import the file every time that it was called. So if you had 15 different Sas files that were importing the same variables file, for instance, then that would be imported 15 different times. There's also an issue with naming collisions because things are imported at a global scope. There can be collisions there, and it uses the same terminology as the CSS import statement, but does not act in exactly the same way. And so instead, they are recommending the use of use. And use is pretty cool. It compiles the style sheet a single time, regardless of the number of times it is used. So if you have that same 15 different imports of the same style sheet and you're using the use @ rule, it will actually only be brought in once and just referenced back to that one time that it's brought in, which helps with compile time as well as the size of the build. You can also set private variables that are only referenced within the file that they are declared in. And namespacing, which again helps with collisions. It also adds a sort of programmatic, it makes SAS feel a bit more programmatic. I'm able to import things and rename their namespaces, able to access things as sub namespaces within each other. It definitely helps to fit things into a more programmatic structure. There are some limitations with it. So currently it's only supported by Dart Sas compiler. So if you are using libsas, it is not supported. Some libraries don't support it yet, namely a majorly popular one, Bootstrap, does not support use. And your project may already be optimized by other front-end tools that you're using. So I played around with this for quite some time, trying to get the build files to be different sizes on a Next.js project that I was working on. And Next.js was doing some cool front-end optimization, and no matter what I tried, I could not get the build files to be different sizes. So if you happen to know what Next.js does to make that more efficient, I'm dying to know because I could not figure it out. But if you do just, if you're compiling the Sas in a more normal, manual way, it does make for a much more efficient compilation and build size. That's it. Just a simple little tip.
Cool. Thank you very much, Teal. That was great. Any questions for Teal?
Awesome. Thank you.
Cool. Great. Awesome. Cool. So next up is Yvette. Yvette, are you online? Yes.
I'm here.
Yay! Yvette has arrived. Cool.
Right.
All right. Yvette, you are up.
Okay. Hang on. Okay. Can you guys see the slideshow?
Yes. If you want to hit the hide link that's showing
hide.
about, there's like a hide.
Yeah.
There you go. Yeah. Now you're good to go.
Okay. I'm talking about how you could help us get funding for the Code and Supply Compensation Survey. In case any of you guys work for a company or have a company that wants to sponsor. So Code and Supply, as you guys know, is a tech organization, and we do, we have a co-working space, and then we do talks, and then we have the Slack workspace that has almost 4,000 people, and then there's another few thousand that attend some of the other activities and conferences. And mostly it's community building in Pittsburgh, as you guys know, where we all try to learn about like current events. And, you know, a lot of us are learning about COVID right now. And then there's the tech stuff, about the languages, pretty much any topic like Code and Supply has some kind of community for it. And here's an example of some of the bigger events that we do. We have Hard Facts and then some of the other conferences, and we have meetups like this one. And this is the co-working space. And we are looking for corporate sponsorship for the survey. This is some of the stuff that the funding would go for. So we have a survey tool that we generally pay for, and then we do advertising for it. So we can like post on different boards and get the word out, and all that takes time. And sometimes you have to pay to do that. And then community outreach, hosting for any of the software we have and any of the details that need to go with it. And then it does take a lot of time, like a few months to over a year, like last year, to get everything analyzed and completed and written up. So I would probably incentivize people to work on the survey more consistently if we were able to pay them. So this is some of what happened in 2020, which if you guys were at some of the other talks, we talk about the survey a little bit. We did publish it. It's out on the Medium site, and there'll be a QR code if you wanted to read about it. But it does take quite a bit of work. And if you sponsored it, you'd be helping Code and Supply in general. This is some of what we're going to look into this year. Really similar to last year, but it's going to be shorter than last year's. So we can spend a lot more time, like be more effective with the analysis. So wage gaps, job satisfaction, where people live and work, how they recharge, and then the compensation habits or compensation that people get, the PTO, and then their lifestyle habits. Recently we did a micro survey. We got about 40, we had, about 40 or so respondents to that. It was about PTO and how much your employer gives you. And this is, since I'm up here, I wanted to give a little overview of the results from it, which we're going to publish in a Medium article, but I also made a QR code that you can scan if you want to read the entire results as the Google form. And at the bottom of it, we did ask people their thoughts on PTO policies and had like a free text section. And there's some really insightful comments in there. But your sponsorship would help with the efforts of the surveys. Here you go. I'll give you a second if anyone wants to scan this. And I will drop this in the chat channel as a follow-up to this. If anyone wants to look at the link and they missed the QR code. And then here's a little bit more on the micro surveys that we did so far. So we had pandemic work life, about a chat that might replace the Slack, people's comfort level with resuming meetups, and then some more on compensation surveys. And here's ways that you can help. You can talk to Colin if you or your organization want to donate money to this. And then you can also join as a paying member or tell your friends. And then here's some more ways to get involved that don't involve money. You join the team survey so you can get details. And if you want to help with the survey, you can join there too. And talk to people about your salary and tell your network about the opportunity to sponsor the survey. This is the link I was telling you about with the write-up if you wanted to see where the corporate money would be going. Did someone say something? And that's it. Anyone have any questions?
Cool. Thanks. Mark, go ahead. you've got a question. Mark, if you want to unmute, you can ask your question. If you're raising your hand. Otherwise, we will.
Sorry about that.
Oh, there you go.
Having technical difficulties over here. I do not have a question.
All right, no worries. Cool. All right. We shall continue. Bruce, I think, is next. Right? Yeah.
Okay, then. Let's see. Find my share screen button. Yeah, all the buttons. It should work. Let's see. Hang on a second. It's such a mystery. What are we doing? Hang on a second. Oop. Okay, here we go. All right. So this is, in some ways, an aspirational talk.
Bruce, are you intending to share slides?
Yeah, didn't work.
No, I'm not seeing anything locally nor on the stream.
Hmm.
You want to try to reshare?
Yeah. Interesting. So do you see it now? What are we doing?
Not seeing it on the neither on the stream nor on you. So maybe you want to reconnect. We'll move on to the next person and come back to you.
Sounds good. Yeah, I tried it earlier. That's funny. Okay. Yep.
Yep. No worries. Sarah, that's you next. You are ready?
I think so.
All right.
Oh, wait,
cool.
I see Bruce's slides now.
Ah, what the hell? I see Sarah's slides.
Weird.
Oh yeah, there we go. Ah, okay.
Here,
Go for it, Sarah.
I'll stop.
All right. Go ahead, Sarah.
Oh. I think there's just delays. All right. We'll try this and see how it works. So hello, everyone. My name is Sarah Withy. This is easily building web crawlers for data gathering and maybe fun too. So if you're wondering what a web crawler is, sometimes they're called spiders, but a web crawler, spider, or search engine bot is something that downloads and indexes content from all over the internet. Get it? Because a spider crawls across the web? Yeah, it's cute. So you might be thinking, like, why would you do this? And the obvious answers are for search engines. They would go around looking for pages and then catalog them in their big archive of search engine things. You might think of also like archive.org, which tries to catalog not just websites from around the internet, but like different versions of them over time. But some less obvious ones might be for data gathering. So if you need to like go through a page and try to look for like little pieces of data that's on a website. You might have text analysis. So let's say you're trying to like look at a whole bunch of song lyrics and from like lyrics.com or something and try to do something with those. You could, use a crawler for that. You could do like cataloging data. So if there's like an online store, you could maybe like pull out what all the products are off a particular page. You could also learn about competitor sites. If you had a competing store, you might crawl to find out like what their prices are. Maybe you could set yours slightly cheaper. So there's a lot of different reasons why you might crawl the web. But my use case was that I work for 18F, which is a software consultancy within the federal government. And my first project was to work with the Department of State's Educational and Cultural Affairs Bureau. And they have 10 public-facing websites. And basically, all of these are extremely out of date. They're not responsive. They just have tons and tons and tons of content. The users are not really getting what they need to out of these sites. And so we needed to gather like a whole bunch of data, talk to a whole bunch of people. And I found it was really hard to actually just kind of navigate these sites. So I needed to gather like not just where all the content's hiding, but all the different types of content we had. They actually didn't know how many social media accounts we had. We had to kind of go through and figure out how many they had and a whole bunch of other things like that. Because I do work for the federal government, all of this is like my own views and opinions and stuff, but this is actual like code derived from what I did on this project. I found this really cool framework called Scrapey. It might possibly be called ScrapePy because of Python, but I'm going to call it Scrapey. So Python plus this framework makes it really, really, really easy to create little spiders and crawlers. They call them spiders. I tend to call them crawlers, but basically the same thing. So the basic structure is once you install the framework, wherever you decide to make this directory, you can kind of, actually I realized that import doesn't really matter on the second line because that's a thing I wrote from my personal project. But you basically create a class, you can call it whatever you want. It has to inherit from Scrapey's spider class. And you give it a name. So like mine could be Sarah's crawler. The allowed domains would be just whatever domains you want it to crawl through. So in this case, maybe like my personal website and Code and Supplies website. And then a starting place. And this can be one or more URLs also. So I just start at like my own personal web page. And then you have a parse function that just tells it, what do I do with each one of these pages? And once you build this, you can just run it with Scrapey crawl and then whatever your spider name is. You can also test out some things. So if you do Scrapey shell and then whatever URL, it will actually like pull in the first page. And then you can kind of test out a few things and see how it will like parse out pages, or it will descend into other pages and different things like that, which I don't have enough time to really cover like how a lot of that works. But a really simple example is taking that prior framework, and if I'm writing the parse function, if I open up a file called urls.txt, and the A is for append. So since we're going to keep going to a lot of pages, we kind of want to append to this file. And so I'm going to find response.url. So the response is just, I make a request and I get the response back from the server. So the URL would be whatever the URL of this particular page is. So I'm just going to write that to the file. And then I'm going to say for every href, so hypertext reference, inside the response, and then I can use an XPath to locate every URL. So inside of every A tag, I'm going to look for that href attribute in there. I'm going to get all of those. So for every single one of those I find, I'm going to basically tell Scrapey to do another request for that URL and then parse it. So you can see this can grow exponentially, but the nice thing is Scrapey kind of manages that request system behind the scenes. So you can actually limit like how many pages it's trying to do at the same time. So the yield just kind of says like, hey, I'm going to pass this over to you. You kind of take care of doing whatever you want with this. Now, this is really great. This is super simple. You got basically like 5 lines of code plus, a few more on the other page to parse out, websites, and it will just kind of go infinitely as deep as it needs to within the domains you told it to. But there's a few problems. And the first is that you can actually have href links to other sites. So one that makes sense might be https:// whatever. But you might have like FTP:// whatever, which is not, you can parse it, but it doesn't, it's going to give back results that don't render HTML pages. They kind of render like directory structures. Then you could have like JavaScript : and then do some sort of action. You can't even really parse those pages. You have mail to, which is an email address. You can't parse that. You don't actually go to an email address. And the same for a telephone number. You can't actually go to a telephone number. That's kind of an action that you tell your device to do. So these aren't really pages you can scrape. So you kind of have to start filtering out for those. And the next thing you do is you have maybe other kinds of pages you can't scrape. So all of these are valid things you can link to. You can link to PDFs, which are great, but they don't render like an HTML page. So you have to find weird ways to parse through those. Same for like Word docs. Animated GIFs, I don't think you can really parse those in sort of a text-based way. Same for MP4s or Excel spreadsheets. So if you did decide to write a scraper that was to go into these, you probably have to like do a lot of like weird over the top stuff. So these aren't things that I can really scrape normally. So we kind of had to filter out for these. And then there's maybe pages that kind of you don't care about or kind of throw out the results a little weirdly. So one might be any sort of search page. So like if you had like a click here to go look at, all the number of times I reference something, you might have like a search with a query string on the end of it. Sometimes there's also refer pages that have like various terms, or UTM usually refers to like email-based refer things. You want to kind of chop those out. You don't really want to keep traversing those, because the more of those you keep tacking on, you just add up more of the same page you're already probably indexing. Same for GA, that's the Google Analytics. Sometimes that tag gets kind of appended onto a page, so you might want to ignore those. And the other thing was, sometimes I found links that actually redirected to like site.com:443, which is the secure port for the same domain. 80 would be the insecure port. So if you have some links that have some of these things and some links that don't, you basically get the same page in the end, but you would be cataloging it twice. So I found like I really wanted to filter out some of these extra things to make sure I didn't like re-catalog them, re-scrape them. So I did write a couple of helper functions. This one's a basic one that if I found a port number on the URL, I just kind of chopped it off. So it replaced .com:443 with a .com. Same for the terms, the term refers. If I found any of those, I just chopped them out. So they were usually at the end. I could take them out of that query string. And then same for the Google Analytics tag. I just kind of like deleted them. They almost didn't really matter. A couple of them are repeated, and that's just because sometimes I had the ampersand, sometimes they didn't. You could probably rewrite that with like a question mark to do the regex. I think I didn't think about that when I was writing it, but so this little filter function kind of filter out some of that extra junk. And then I also made a check link thing. So basically, if something about the link through one of these flags that I didn't want to parse through it, I would return false. Otherwise, I would return true. So if like for some reason the href was empty, which came up in a few weird cases, we don't want to parse that. If it came up with pounds, that's like a link to or a jump to another part of the page. We couldn't really parse that. Same for JavaScript, same for .pdfs. And there were so many of these. I ended up with like 30 of these, I think, that I had to kind of write in to parse out. Like I didn't want to go to Word docs or Excel docs or some of these things that I found on the site. And then same for, they had some of these search engine links. They use Solr, and so all the search paths had Solr attacked onto it. So it just basically said, like, I don't care about your search results. I don't want to catalog those. I just want the pages by themselves. And using those two functions, I kind of rewrote this. So my new parse function down here, so I'm still going to go look through like the for href in all of the hrefs I can find. If that check link passes, so if that's a link I do want to go into, then I'm going to rewrite it. So I'm going to use that rewrite link to chop off the extra terms I don't care about. And then I will pass that over to Scrapey to go request again. So it's a little bit better example. It tacked on with the other functions. It's a little bit longer, but is a lot more guaranteed to actually run to completion without errors or without going into an infinite loop where it just goes forever. So another thing we had was they didn't actually know how many social media accounts they had. Turns out they had over 700, which is remarkable to me. But I kind of wrote this thing. So it's a little bit revised. So instead of writing to the file, I actually look for throughout the body of the page, anything that referenced facebook.com/ some form of username. So like letters, characters, and a dash. Same for Twitter. I actually looked for Reddit, Instagram, so many other things too. I didn't end up finding any, but so I'm going to take those results. I'm going to combine them together. And then with that, I'm going to open up socialmedia.txt. And for everything I found, I'm going to write that on its own little line. So I just end up with a whole bunch of facebook.com/whatever, twitter.com/whatever. And then from there, I'm going to go look for all these hrefs and I'm going to descend into those. Since we're finding all these Facebook links, it's not actually going to parse them because it's filtered out by the allowed URLs in the beginning. So that became a really simple way that in I think it was about 10 lines of code, mostly looking for like the social media accounts that I quickly found all of them in the site. And by quickly, I mean, it took like a few hours to actually go through all their site. And then we found out in the end, they had like 20,000 pages of content, which was remarkable. And no wonder it took us so long. And then a couple other things that were really handy I found is that if you wanted to parse out the titles, you could look for that response and then look for the XPath of the title tag and then pull the text off of that. And then same for if you wanted the URL pass without the domain on it, you could just take response.url, split off everything before the double slashes, and you just kind of keep everything after that. So actually, that would keep the domain name, but just chopped off the HTTPS. So that's the basics of this. If you have any questions, I'm more than happy to kind of explain any of it. You can hit me up on the email, the Twitter. I am on the Code and Supply Slack. You can hit me there. I will post this up on web crawlers. I might make a couple revisions to the slides that I found as I was going through it now. But that's this in a nutshell.
All right. Thank you very much, Sarah. That was great. Any questions for Sarah? Craig, go ahead and unmute and ask your question. Craig, are you there?
Maybe Craig accidentally hit it.
Yeah, I'm thinking
That'd be my best guess. Yeah.
All right, Bruce, you are up next.
Okay, we'll try this again.
Yeah.
I set up my other laptop so I'll be able to tell if I'm successful.
Hey, there you go.
There we go. Okay. So can I also turn my video on, or does that not work?
Yeah, if you.
I don't know. Yeah, whatever. Anyways, not worry about it too much.
There you go.
Yeah, it caught up with me. Okay, cool. And yeah, it looks like my picture's on there too. Cool. Anyways, JSON formatting. Why would I care? Well, I care because I need to read JSON, I need to write JSON, I need to communicate with other people, which is really the important part. And this is other people working on my project. It's partners out there in the world, or trading emails back and forth. Well, this is an example of what you're sending us, and that's not enough. I need more info, and that kind of thing. So that's all happening now. As a programmer, I want, do I know how to drive this thing? There we go. I've been very inspired over the years by, especially Go format was the first one that I'd run into that was like, this is the way we format Go code, period. There are like no options. It's like, that's awesome. I'd lived in a Java world where there were a gazillion options for how to format and 700 opinions. And I was actually on a team on a Java project where we all had to use the same IDE so that we would get the same formatting, because that's the only way we could set up formatting. So of course you could check formatting in CI. You couldn't, I mean, anyways, currently live in a Python world. Black does that same sort of thing. It's almost no options. There's line length and one or two other things. And it's like, okay, so I'd like to do that or something like that for JSON. Oh yeah, so is JSON code? My opinion is yes, it's code. And so formatting it is relevant, makes it easier to read, makes it easier to share. It means that if I edit it and my text editor reformats it on save, you know, I haven't changed every single line in the file because we've got an agreed on coding standard. And at the moment, the project I'm working on, we've got a lot of JSON. I'm surprised to find how few JSON files we actually have in the repo. I thought we had more than that because basically all our tests are Awful lot of our tests are based on JSON or the CSV files. Is JSON also documentation? Kinda. I certainly have ended up with trading JSON with people in email and Slack a lot, occasionally in presentations. So it's kind of documentation. So let me dive into some JSON. This is an example of trimmed down example of a transaction, a credit card transaction. And this is, I mean, it's trimmed and private stuff's been pulled out. But yes, I actually bought ice cream in mid-March at Millie's, which is 2 blocks from my house. And we got, the system I was working on at the time got a record with a whole bunch more than this of, yep, Millie's, date and time, how much, fee, and of course, this is US dollars, so dollars and cents. And I tried formatting it with my very favorite, go-to JSON tool, JQ, which is fine. Although the dollars and cents, like that fee that's 0, it's just 0, not 0.00. I guess I can live with that. Then this available balance, 148.7. That's not human friendly. I mean, the number's right? It's $148.70. But it's a little weird. So let's, I'm living in a Python world. What does Python do with it? It's basically the same. Python decides to treat that 0.00 in the source as still being a floating point number, so 0.0. Meh. Yeah, okay. And now I've been playing around with the tool FJ, format JSON, which is built in Rust using the Serde library that is an amazing library in the Rust world, in Serde JSON, and telling there's an option of that library that says keep full numeric precision. That actually preserves the trailing zeros instead of dropping them, which is happier. Again, the previous numbers weren't wrong. They weren't as human friendly as I would wish for. Seeing those other tools, I mean, JQ and Python messing with the numbers, it's like, well, what happens if we get to extreme numbers, like numbers with a lot of digits? Well, JQ just drops precision. Python, well, it depends. If Python decides it's an integer, it actually retains all the precision. But if it decides that it's a floating point number, which is there's a decimal point in there, now switch to a float and loses precision. The Rust tool that I've been experimenting with preserves full precision. It's like, woo, okay, nice. At least we're not breaking things. So that's numbers and is clearly solvable. I kind of wish there was an existing formatting JSON formatting tool out there in the world that did this, but I'm not aware of one. And there's, okay, what else might be interesting once we're talking about formatting JSON? And JSON supports Unicode. Actually, the standards largely call for it to be UTF-8. One of the standards says it must be UTF-8. Most of them just say preferred or presumed. If you're not, you don't have some reason to think something else. I was interested to see JSON supports a particular style of Unicode escaping. And depending on the tool you run it through, JQ will always take, if it's a printable Unicode, it'll do the printable, the shrug there, and switch the Unicode new line into the simpler new line escape. Python always goes the other way. If it's high Unicode, basically if it's not ASCII, Python will display it as the as the Unicode escapes. And this is, if I were in the room with you folks, I would be asking you, so which would you like to have if you were formatting this stuff? But that's less practical when we're all on remote here. And then there's crazy stuff. The JSON standards actually allow for the same key multiple times in an object. They say, you probably don't want to do that because, like, what does it even mean? All of the tools, including the tool I've been playing with, just throw away the earlier. I mean, I've got that source document up here is key 1, key 2, key 3, right? And you always just get the last one. It just overwrites the earlier ones. So I would certainly, part of what inspires me about code formatting tools like GoFormat or Black, or cargo format in the Rust world, is that they don't break anything. You can run that formatter and know that you're not going to change the code. You're not going to change what it means. And this kind of thing, what if somebody actually needed those multiple keys, had a reason to have them there, and I ran it through a code formatter and I threw away information. I don't like that. As an aside, I've actually written a tool that will, under certain circumstances, spit out JSON with repeated keys. We can talk about that in Slack another time. So, formatting JSON. I'm still looking, or maybe I'll build one. And there's just some references. I mean, I think most people here probably have at least heard of JQ and the Python's JSON tool. And Rust Surdays is very nice. Yeah, find me in Code and Supply Slack. I'm the one with the flower in the middle of my name, which is grandfathered in. You can't do that in Slack anymore. So that'll be my name forever in Code and Supply Slack, because I don't want to change it because I can't put it back.
Indeed. Bruce has been around since the very beginning.
There's the stop sharing button. Got it. All right.
All right. Cool. Thank you very much, Bruce. That was great. We've got one more talk for you tonight, I think. Bryce Allen is up next, but while Bryce is getting ready, I've got one more little adlet to do here. So we'll do that right now. So we do have merch. We have some winter merch. We have some awesome beanies that I absolutely love wearing my beanies everywhere. I also have a couple of Code and Supply sweatshirts. There's all kinds of stuff you can go and get there. If there's some kind of geeky thing you'd like to see on a t-shirt or sweatshirt or something, let me know, and I might even just go do it. It's not in this particular image, but somebody suggested a can't fix, won't fix t-shirt. And I went and made it, and it sold out. So that was kind of cool. In fact, it sold out so quickly that I wasn't able to get one. So somebody really liked it or shared it widely. So yeah, that's a thing. Go check it out. codeandsupply.co/store. And then our final talk tonight is Bryce.
Hello, everyone. Can you hear me?
Yes.
Yes.
Okay. Now let's see if I could share my screen.
Awesome. We can see it.
You can see it? Okay.
Yep.
It's amazing when this stuff actually works.
I know, right? All you.
Okay. Is it full screen now? Oops. Go back.
It is not full screen to us. We're still seeing your entire, well, not your entire screen, your the window that you're in. And now we have lost the share.
Okay, let me me just entire screen. Let's try this. Okay, is that
There
better?
we go. Yes.
Okay, so my name is Bryce Allen. I work for, I'm in Pittsburgh now, but I work for the University of Chicago. I'm currently working on getting a fusion simulation code to run on the next generation of supercomputers. And before I started this job, I did not know GPU programming, and I did not understand plasma physics at all. I still barely understand plasma physics, but I have more understanding of GPU computing. So I'm going to try to give a quick whirlwind tour of why we use GPUs in high-performance computing and an example of what the code looks like. So, I mean, I'm sort of looking at this from a certain angle of plasma physics simulations. Obviously, there's also a lot of machine learning going on in high-performance computing, but I'm going to focus on the physics simulation side of things. In a lot of these physics simulations, there are differential equations that have to be solved numerically. They're fairly complicated sets of equations. And we have to solve them numerically because there's no nice, clean, closed form solution in a lot of cases. So we basically chop up our continuous functions into arrays with values, and like basically a derivative becomes a difference. That's like a cute way of saying talking about a very complicated field. But and then the mathematical tool we use is linear algebra, which is arguably undertaught in the US because it's, I don't know, used a lot more in practice than calculus in some ways. Okay, so why do we use GPUs? So the short answer is that GPUs are super fast at linear algebra. But some other notes, in high performance computing, the new supercomputers have multiple nodes, each with GPUs on them. So we have to break the problems up into smaller subproblems. And communication is very important because you have to exchange boundary points. So you can't just use some like loosely coupled cloud with Ethernet on it. You need really beefy, high bandwidth interconnects. So there's this whole specialized field for high performance computing. So this is an example of a test machine for Frontier, which is an upcoming supercomputer at Oak Ridge National Laboratory. So it has a very beefy EPYC CPU with 64 cores. But compared that to the GPU has roughly 6.5 times the peak flops. And this each node actually has 4 GPUs. So it's like 25 times as much computation comes from the GPUs as the CPU. And almost more importantly, and often not talked about, the memory bandwidth is 6 times higher on the GPU. We'll talk about that a little bit more. Okay, this is a block diagram for a slightly different GPU from NVIDIA, but it's pretty similar. So you see this, I think this was 80 cores or something, and each one has a ton of vector units. Whereas the CPU will, I mean, there's some convergence here. Like that CPU has 64 cores, but it only has a small handful. Oops. A small handful of vector units. Okay, so that's just a motivation for why we use GPUs. So here's a super simple example. Let's see if I can show the animation first here. Okay, and now it's refusing to run. Okay, let me try something else. Okay, can you see that?
Yes, we can see that.
Okay, so the idea here is this is kind of the toy example everyone uses for numerically solving differential equations is heat diffusion. The rate of change of temperature is proportional to the curvature. So if you have a very curvy temperature profile, then it evens out more quickly and spreads more quickly. So this is my little toy example. Let's go back to presentation mode. Okay, so you can imagine a 1 meter rod where the temperature is fixed at 0 because you have like a huge reservoir on either side, and that little crook in the profile was because I added a point source for heat at 20 centimeters. So the way this looks in code on the CPU is you have an array with the temperature at different positions along the rod. And at each point in time, you're basically just averaging neighbor points in a very specific way that matches how that particular differential equation works. And here, each time step is based on the data from the previous time step. So here, instead of swapping 2 pointers around, I just do it twice each time. And then every so many time steps, I write the output to file so I can plot it later. So that's what it looks like on CPU. This is Julia code, but probably familiar with anyone who's used MATLAB. Okay, and then on GPU, the fun thing about GPU programming is that it's not just about getting the compiler to understand that you want to vectorize something. You have to do a lot of the work yourself. So this is why so much work is going into all these scientific codes to rewrite them, and people like me are getting jobs. So you can ignore a lot of this, but basically the way this often works is you write the inner loop, and that's it. So here, I'm actually handling multiple points here in case, for reasons I won't go into, but basically depending on the size of the GPU, you don't have enough SIMD units to have one handling each point separately. So you have one thread of execution handling multiple points. But it's basically just the inner loop here. And then when you launch them, you tell the boundaries of the loops. And then the GPU goes and schedules these things. You generally oversubscribe it. So while one bit of code is waiting for data, another bit of code is running. And that's just a quick flavor of what it looks like. Okay, thank you.
Cool. Thank you very much. That was in Julia, correct?
Yes, that is Julia.
Okay, cool. Haven't seen a whole lot of Julia, and it's great to have another Julia talk. I think it's been a few years since we've had some Julia content for the code.
Yeah, I should make a disclaimer that this is actually really bad GPU code. Like, you wouldn't actually do it this way, but it fit on the screen, and it's the simplest possible example. So
that happens.
It actually runs. I just finished this and profiled it. It actually runs slower on GPU for certain reason. So it's a lot of work to get it. The naive approach often fails.
Cool. It's good to see an example. All right, that basically concludes our lightning talk tonight. I do want to do some quick pitches though, because it wouldn't be me without some pitches. So please do join Code and Supply. A little bit of money goes a long way. If even just like a few of you sign up from having seen these lightning talks tonight, that can go a good chunk of the way and just putting us into a good financial position going into 2022. We do have a job board, codeandsupply.co/jobs. I did realize that I forgot to send out the newsletter. Yes, a little bit should have gone out like Thursday. So I'm going to send that out. Send that out probably tomorrow evening at the latest. But go check out some jobs. I think there are about 2 dozen there or so. And then, of course, merch. I talked about merch just recently. So codeandsupply.co/store. Go deck yourself, deck your halls, whatever you so desire to deck, as long as it is not me. I mean, you can buy me stuff if you'd like. That'd be really cool. Anyway, thus concludes our Lightning Talks night. Thank you so very much for joining us. Whether you joined us on 8x8, whether you joined us on YouTube, please give a clap of sorts to our presenters for their volunteerism and for their information sharing. Code and Supply absolutely loves when people share their talents, share their knowledge. That's what we're all about. We just all want to learn something cool. That's all I got. So long and happy holidays to all of you, and good night. Good luck.